Hi everyone. My goal for Stackathon was to get my feet wet in the Ethereum ecosystem. For those of you that are maybe not familiar with Ethereum, it's a blockchain technology that's known for its programmability. How they solve this is by having two types of accounts basically. We have like Alice and Bob have accounts that you might see in other blockchain type technologies or any sort of transaction system where I can send a transaction to Alice or Bob and vice versa. Ethereum introduces a second type of account called a contract account, which is essentially an account that can receive transactions and then execute code that a developer sort of puts in the account. This is written in Solidity and compiled to bytecode that can address the EVM, the Ethereum virtual machine. But essentially what it does is allow for conditional transactions. So I could send, instead of directly to, say, Jonathan, a transaction, I could send it to a contract that will send the Ether on to Jonathan on certain conditions or not. So basically what I was hoping to do was write a couple smart contracts and see how far I could get with that. And then build a front end using React just so I can interact with them using Truffle.js. And the first thing I did is sort of a hello world type thing. This contract you can see in the terminal there is a kind of local test blockchain that's running. And here is my transaction field. What this does is takes in a message. It will store it on the blockchain in a mapping, which is a Solidity data type that's essentially a giant hash table where every possible key value is already initialized. In this case, I'm using 32-byte data type for storing the message, which is quite short, but storage on the blockchain is extremely expensive, so you always have to think about that. I think storing a megabyte on Ethereum right now costs about $5,000. So keeping things short and succinct is always worthwhile. So I'm just going to add a little message here, hello world. I'm going to hit transact, which is going to bring up MetaMask, which is a sort of wallet layer. I have a bunch of kind of fake accounts set up here on my fake test blockchain, and it's going to ask me to confirm the transaction because any transaction writing to the blockchain is going to cost gas, transaction fees basically. Reading is free, writing is expensive. So I'm going to submit this. It's not going to come up right away. I have a check chain button because this is a very asynchronous action, obviously. It's going to have to wait until the block is mined before this reflects. And in my case, on the testnet, it mines rather quickly, but block time currently is around 20 seconds. So getting this hello world done, I kind of thought, OK, well, let's maybe go for FizzBuzz, and started thinking about what's a more complicated contract that I could come up with. I think it's a tricky thing to think about blockchain ideas because, as I said, it's very expensive to write for you, but it's also expensive for the sum total of the network. It uses proof of work algorithms use a lot of electricity. It's not something that you necessarily want to do something really frivolous with. So the contract that I wrote and have a bit to show, but it doesn't really work. I thought about geocaching games. And the idea that a smart contract could maybe enable putting bounties on geocaches so that if you went out, anyone could post a geocache with locations. A geohash maybe is the most reliable way to store it, and where you write a code, a secret code on the bottom of the thing. So if you find the thing, you can turn it over, you now have the code, you can send a transaction to the account which has stored a hashed version of that code. It will check the code you inputted against the hashed storage, so it's cryptographically secure even if you inspect the contract. And if it's correct, it's going to release the Ether to you. Geohashing is not like a super important thing necessarily, but the reason this is a nice application for a blockchain is because it does something that they do very well, which is create a sort of trustless scenario. In other words, you don't have to trust a kind of website to pay this bounty out. You don't have to trust the person who put up the site. You can just trust the code in the contract that if I find the code and enter it, I'm not going to get the site showing. I had a similar front end for this as well. It would pay out the bounty for finding the cache. There you go. So Lady on the Lake has a geohash, has a range within the geohash. If you go to this spot, it's going to be within 500 feet. There's your bounty. There's a hint. So maybe this is a Barbie doll put on a lake in a specific spot where the sun hits around say 11:45, right before noon. And then you could go here, enter the code, solve the cache. The contract will check it. If you're right, it's going to send you the bounty, which is 1.25 Ether, and close the contract. So the contract's working great. You can interact with it on the command line, but it is not hooked up completely to the front end. But that's how far I got. It was really fun to dig into this. Challenging at times, but it was really exciting. Something I wanted to look at for a long time. And that's where I got.